I graduated with an industrial engineering degree, which I guess in the bigger picture of things, an industrial engineer is kind of the crossover between the business world and the engineering world. So I went through your typical engineering courses, the mathematics, the physics, the chemistry, and on top of that, being an industrial engineer, we had to go through a lot of statistics and workplace design. My project here at Honda was at our Marysville Automotive plant in our vehicle quality department. At the beginning of the vehicle quality department, there's a few sets of machines. The first set of machine was the swap machine, which is a steering wheel alignment tester machine. It assures that all of our cars are kept in line when you're driving on the road so that there's no pull. The second set of machines was our dyno machine, which tests the engine and the transmission components to make sure that they're performing at a proper level. What the project pretty much entailed was they were noticing a lot of cars backing up in front of each of these machines, so they were unable to make cycle times. They requested me, since I was an industrial engineer and have been formally trained in statistics and a lot of higher concept mathematics, to come in and actually apply those skills to this project. So we went out and we took our cycle time calculations from a stopwatch, and we also broke down the process a little bit more using some more data gathering and counter gathering from a lot of the control logic in some of the equipment. And what we were able to do is to gather statistical data and really look at some of the distributions and what's called the noise of the process. Through that, we found that the statistics of the process were modeled more toward a log normal distribution, which gives you a little bit more variation in the process. So we tried to really understand and learn as much as we could about the process and the breakdown of the process, but we hit a brick wall. So what we did then is we went back and we used a discrete event simulation package, which allowed us to test the processes using these log normal distributions and exponential equipment breakdown distributions, and really test for these thousands and thousands of random variations. So the ultimate result was we were actually able to raise the capability of those two machines on average 15 units per shift, decrease the process requirements. So that essentially made the associates that do these checks, they made them more efficient. So discrete event simulation package, it helped us better define what the process was and how we could overcome a lot of these issues to really be able to come up with the most robust solution to a lot of their problems.